and we'd have seminar in the same room, so we'd have all this food. But it's the director of the institute and keeps certain things.
So John May was on Larry Mantle this morning.
He was?
Yes.
Why? For what?
They were talking about Google's point-making bot.
Oh, okay. So
did he approve of it or not?
Yeah, he said he was impressed, but he noted that all he saw was what Google wanted to show.
Yeah, there is no demo system to use. It's just, yeah.
This morning I was trying to use Siri. So text my daughter. I said, tell Miss Riola that you will be out. And she says, I'm ready to send. And the message I'll get was tell. Out of my entire thing, she said tell. All right, let's give it a few more minutes. I think people are lazy, basically. Hello.
I tell Siri to call my girlfriend Molly. Half the time before it actually does it, it'll get right in the end. It says Maui, as if I want to call the island of Maui. It makes sense, but that can't be the likely match given who's in my address.
So anyways, Jerry, despite Google's successes, we have a long way to go with conversational assistants.
That doesn't matter because I'm going to retire soon.
Okay, I'll be looking for John May.
The problem at least remained for my whole career.
Any other movements?
I think Amy was asking around.
And notice how much we dislike each other. Everybody strategically position themselves.
That's okay.
So it looks more crowded. Even if it's distributed.
And by the way, sorry, Amelia's
Get the
daughter is
seating
so
out.
Yeah. All right, we're going to start. It is my pleasure to welcome Umashanthi. She's interviewing for a postdoctoral position here. So Umashanthi is getting her PhD in Georgia Tech with Jacob Eisenstein, who studies for like a linguistics question dynamics of change. And Umashanthi has been working in data science at a number of locations. At FAY, you had some internships. Working in data science with Facebook, with PNNL, who we actually working closely with right now, and also at Indiana University, that was that Insights Group. So we are going to hear what her dissertation topic is about.
Okay, thanks for the introduction and thanks for having me. I'm really excited to be here today and talk about some of my work. So today, our social, personal, and political lives are increasingly mediated by technology and computation. So for example, there's recent issues about automated bots being potentially affecting political outcomes. Fake news is a problem for platforms like Facebook. These online platforms are also kind of trying to spread conspiracy theories and rumors. There are also other issues like algorithmic curation and filter bubbles. So these changes has introduced new problems such as echo chambers, hate speech, spread of rumors, and a lot of cyber threats. But it has also brought some exciting opportunities for us to understand the social world using data and methods that early social scientists could only dream of. So now we have this opportunity to understand about social phenomena using computation and also to address some of these social challenges at scale. So these changes has led to this emerging field of computational social science, which in one way we could think of as a combination of social sciences, quantitative methods, and computer science. So this is the broad area where I have been working on over the past several years, and this is where I have most of my research contributions. So this is an exciting time to be working in computational social science. And so we use computational methods to model domain knowledge to answer social science questions. If you think about this, about the field of computational social science, there are also challenges in using data sets and computations to model and study human behavior or answer social science questions. Here I've listed some of them. The first one is about representativeness and generalizability. So we use data sources from various different sources to study human behavior, and sometimes we don't know how these data sets are collected and how good are these? Are they representative of the actual population we want to study? And can we generalize finding from a particular data set to a larger? Another challenge is about feasibility of doing randomized experiments. So social scientists are interested in doing randomized experiments and asking causal questions. So one is about the feasibility of doing randomized experiments, and if not, how we can use observational data to kind of approximate or answer social science questions, answer the causal questions. The third one is about so the third one is about validation and evaluation. So when we model social phenomena, social science intuitions using computational models, we need to make sure that we validate what we are modeling. Whatever we're modeling is actually capturing what we wanted to capture. So these are some of the challenges which I have addressed in some of my work. And in today's talk, I'm mainly trying to talk about two of these kind of directions or challenges. The first one is about representativeness and generalizability of different data sets. So here I'll talk about a particular case study where we looked at GPS tagged to the data and how does that the biases affect language predictions and inference. And in the second part of the talk, I'm going to talk about how we can use observational data to answer kind of a causal questions in different social types. So in this part, I'll talk about 3 different case studies where we have studied interventions on Twitter, Reddit, and Wikipedia. So now moving on to the first part of the on representativeness and generalizability. So in this work, we looked at the biases in GPS tagged to the data and how does it affect geolocation prediction. So there's an increasing amount of research in social computing, natural language processing, research which uses geotagged social media data for various inferences and predictions. So for example, in natural language processing, GPS data is used to study geolinguistic inferences and text-based geolocation. But how good is this data set? And how representative is this data set for the actual user population? So can we generalize findings from using GPS tag data to a larger population? So if you look at this picture, so this is the 2013 urban-rural classification scheme for different counties in the United States. So this shows that these geographic regions are not the same. They have different properties. And some of the recent work has shown that social media data, especially geotagged Twitter data, is not geographically representative. Most of the time, it's often drawn from the urban cores and it underrepresented these rural areas. And most research uses social media data for geolocation prediction and location-based studies such as political opinion and public health issues. But only about 1.6% of Twitter data has this GPS coding. So this tells us that these samples are very skewed and does not represent the entire population. So we can't generalize findings from just that kind of sample. So in order to kind of look at this geographical representativeness of Twitter data, what we did was we looked at this proportion of proportion for each different counties, or proportion of the census population, the Twitter messages, and the number of users on Twitter from that particular county. So on this, on the left, on this one, you'll see. So this has different counties in New York, And you'll see this most populous Brookline area is underrepresented, while this commercial center of New York Manhattan area is overrepresented. In Atlanta, we see again the similar pattern of the city area of Fulton County is overrepresented, while most other counties are underrepresented. To study these biases further, we created 3 data sets using location information in tweets. So one is from the GPS coordinate, which comes with the metadata on the tweets. And the other one is using the location information in user profile. For most US users, we found that this is a combination of the city name and data. Use this kind of code for the location. And then we created these 3 data sets. The first one is about, we looked at top 10 major cities in the US, and the first one is about US data. The same number of metro area. And then in the second one, we resample the first one to balance it for the county census population. And the third one is about the location, the sample based on the location. So I'll quickly tell about some of the kind of the demographics inferences we found from this data set samples. So in this figure, it shows this difference in the age distribution of these GPS tagged Twitter data and location-based Twitter data. And we see that these younger users geotag their tweets more often compared to the older users. So there's these age distributions are different in these different type of, when we create data sets using different kind of location information.
Wait, how do you get the age?
Sure. So for this one, we used it use the first name of the user profile and use the census statistics, the social security statistics to kind of infer the age of these people based on the first name. And then we used, for a later part of this work, we also used the text of it and then use a machine learning model to infer it, yes. We also find that these women geotag their tweets more often than men. So we see there's this kind of different biases based on different social variables. So we often use these social variables to study different social phenomena or social science questions. So in order to further look into it, how does these biases impact downstream task of geolocation prediction? So geolocation prediction is a task in NLP, but it's being used by a lot of downstream tasks. For example, when people study location-based issues, public health opinion, or issues of political opinion, so we use these geolocating mechanisms to kind of further study the population. So we kind of make this task of, so we have tweets from 10 different cities, so it's a 10-way classification. And we got tweets from about 2,500 authors for each of the city area, and use the logistic regression classifier with back. So here our goal is to not build the most accurate geolocation prediction system, but to use a simple method to see how these biases in the data affect this geolocation prediction. So this is what we found. So it's easy to geolocate male authors compared to female. And it's also easier to geolocate older users compared to other groups. So this tells us, when we look at the aggregates, these geolocation prediction systems have very good performance sometimes. But they don't perform the same way for all different social variables. So when we use such aggregated methods, they might not be actually the representative for all these different groupings of demographic geography. So we kind of looked at several further investigations on this. One of this is looking at this intersection of age and gender. And we looked at words which are specific to these different age gender groups. Something we noticed is that all the men write more about local sports related entities and local locations, whereas all the women write more about regions oriented terms. So these different ways could be affecting how easily we can geolocate these different age groups or social variables. So kind of to summarize this part of the talk, so the takeaway from this is that GPS Twitter data is not representative of the actual population, at least in the US US counties we looked at. And so it's skewed in terms of geography and demography. And we have specifically looked at these biases for geolocation prediction for different demographic groups. So what this suggests is that we need to be careful when we generalize findings from such aggregated samples where we don't know the actual composition of these social variables or different groupings of population. So that's the end of this first part about the issue of representativeness and generalizability when we use social data to study different social phenomena. So the takeaway message is that we need to be careful about what kind of data sources we use and how good that is for our task, and then how can we generalize findings from that particular source.
But you assume that your inference of age and gender, there's no biases, there's no systematic biases.
Yeah. So for this work, we this one we also use this like a latent variable model to use the text as well. So that's why we wanted to go beyond just using this social security kind of information. So kind of make it more robust. So
right. But did you evaluate how well that does in kind of an unbiased way?
Yeah, we haven't looked into kind of any like validating that aspect of how well it's done, but that's a very interesting question.
Because if it's be going on based on text,
yeah,
there could be some differences.
Yeah. But to mention that there's also some other work after ours which kind of finds similar kind of biases for these different groups, and some of the downstream tasks is also kind of when they create balanced data set for training, they get better improvements on this kind of prediction tasks. So now let me go to this second part about how we can use observational data to answer causal questions. So let me start with some background. So in this figure on the on your left, it shows that there's a correlation between countries' chocolate consumption and the number of Nobel Prize winners. And on the right, there's this picture about how the usage of Internet Explorer and murder rates are correlated. So those correlations are interesting, and often this helps us to study things further. So another way but we don't know the relationship whether the kind of decrease in Internet Explorer usage actually causes the murder. So another way to study the relationship between things is asking the causal question. So social scientists are interested in understanding the causal relationship between different phenomena. So if we want to ask the causal question, then we need to look at the direction of the relationship. So we need to ask whether X causes Y, or whether the intervention X causes the outcome Y. So one way to study causal effects is to think about the counterfactual. So in this case, we have a subject and it gets a treatment and there's an outcome. Now, if the subject didn't receive the treatment, there will be a different outcome. So this is the counterfactual. So to measure the effect of the treatment, we need to measure the difference between these two outcomes. But the issue is that we don't observe this part, because if a subject receives a treatment, then there's no case of receiving no treatment and the outcome of no treatment. So how can we measure these unobserved outcomes? So we can use a causal inference design called randomized experiment. So this is like a classical design of randomized experiment. What we do is from a population, we randomly select some subjects into the treatment or intervention group, and some other subjects into the control group. So because these subjects are selected randomly from the same base population, we can safely assume that both of the treatment and control group have the same characteristics before the treatment. So the treatment groups receive some interventions, and the control group does not. So when we want to measure the difference between the treatment and control group, then we'll be able to measure the effect of the treatment. Because these both of those are likely have the same likelihood of getting the treatment, but some group did, and the other group did not. So the difference between the outcome will be the effect of the treatment. So it's now, what if we can't do randomized experiment where it's not possible or if it's not feasible? So in most online social platforms, we do not have the control of doing randomized experiments, but there are also a lot of ethical questions about doing such experiments or interventions. So we can use some causal inference techniques for this, and but we should be careful. So let me talk about one factor about confounding variables. So confounding variables is something that affects both the treatment and the outcome. So in this case, I have an example of the relationship between exercise and mood. So there could be one variable, for example, the weather could be affecting whether someone is exercising, someone is going for a run, and it also could affect their mood. So this is something which is affecting both the treatment and outcome. So this is called a confounding variable. So when we don't randomly pick the treatment and control group, we need to control for these possible confounding variables. And then we can use some techniques like matching to pair up treatment and control and then measure the effect of a particular type of intervention. Okay, so I think I've given some background about how we can use this kind of approximating to randomized experiments to look at the causal questions. Now I'll go through these three different case studies. We looked at on Twitter, Reddit, and yeah. So let me go to the first one about the effects of a new linguistic affordance on Twitter. So we specifically look at, in this case, the introduction of emojis to Twitter. So this can be kind of similar to other social platforms. Firstly, let me give some background about online writing. So in online writing, when we write kind of post in Facebook or do a tweet, so in the absence of nonverbal cues which is present in face-to-face, so the way of kind of maybe facial expression, different gestures and tone, we don't have such kind of nonverbal cues when we are writing online. But people have been very creative in inventing new ways to express nonverbal cues using different forms like emoticons and like several non-standard terms. So things like expressive lengthening, which kind of maybe indicate that this is how you'll feel someone says say cool versus writing CWO. And then there's also this different non-standard spellings and abbreviations which are known to convey different social information in addition to just the text or just the verbal information. So recently there's a new form of writing or orthography that was introduced to online writing, so that's emojis. So emojis are becoming, these are predefined set of Unicode characters. They're becoming very popular, and even one of those emojis were named as the word of the year in 2015 and later years. Now, what's the role of emojis in online writing? So here I have some examples from the celebrity Britney Spears. So here you see tweets from her before she started using emojis. So she's using emoticons and several non-standard forms like repetitions, capitalizations, and all of that. When you look at her tweets after she started using emojis, we see only like emoji characters and most of the rest of it is standard words. So do emojis replace these previous kind of forms of non-standard words? So the question is, what's the role of emojis in writing? So why it is important is because we use the textual content from most social platforms to study different social phenomena. Most of the studies so far kind of disregard these emoji characters. But from the example, it looks similar. Emojis look similar to emoticons and other non-standard forms. So it maybe is performing the similar role of conveying social information. So if we disregard emojis, then we will lose a lot of information. We will either miss something or we will misinterpret something. So we wanted to look at this role of emojis. And the way we pose this question is because emojis looks very similar to emoticons and other non-standard forms, and they also looks very colorful and kind of pretty. So kind of we asked this question of if emojis are replacing these previous forms of non-standard order, like emoticons and non-standard. To study this, if we first look at this kind of the trend of emoticon and emoji usage on Twitter, here you see this emoticon rate is going down and emoji rate is steadily increasing. So does this tell us that emojis are replacing emoticons? Not necessarily, because there could be other changes happening in the platform. For example, this is a quick figure from the Pew Research report about how this user composition of different age groups is changing in social platforms. So you'll notice this older people composition, the proportion of older people is increasing. So there's a lot of changes happening. So in order to just answer the causal question, a simple correlation trend is not enough. And we need to go beyond and ask the causal question of whether individuals' adoption of emojis causes a decline in their emoticon usage, and whether it causes a decline in their non-standard word usage. So to study the second question, we pose it as a way as whether it causes the increase in standard tokens. So it's the opposite of decrease in non-standard. So to test this, we don't have control to do randomized experiments on Twitter. But we have observational data. So what we did was we used this observational data to approximate a randomized experiment. Here the treatment is someone started using emojis. And we have this treatment people who have started using emojis, and then we select control people who have never used emojis. And we look at their writing style, that's their emoticon usage and non-standard word usage before and after this treatment point. Because we didn't select the treatment and control as random, as we would do in a randomized experiment, there could be potential confounds that could be affecting both the treatment and the outcome. So in our case, we are looking at language style or writing style. So one potential confound is how people's habitual nature of using emoticons and non-standard words. It would be different for different people. So we match on the pre-treatment emoticon and non-standard language usage. Another confound here is, in this particular case, is about what's the kind of the input mechanism they use to post the tweet. So if someone's tweet kind of got more standard during this period, it might not necessarily say because they started using emojis. It could be because they changed font and that font has a better order correction. So the input mechanism is also affecting this writing style. So we also control for that by matching on the Twitter client they use to post these tweets. So in this way, we were able to get matched pair of treatment and controls. And then we use this causal inference technique called difference in difference analysis to measure the effect of the treatment. So what is this? This is basically looking at the difference for the treatment and control group pre and post treatment, and looking at the average differences, and then taking the overall the difference between these average difference. So the null hypothesis here is that it will be 0. So this is a quick results from this first hypothesis that when people adopt emojis, they are tend to use fewer emoticons. We see that when people use more emojis, the emoticon rate is going down. So this tells that emojis are competing for the same linguistic role of emoticons. The next one, we find that people use more,
So does your method give you a way to estimate confidence interval or significance?
So it's a significant.
Okay.
Yeah. So we measured the treatment, and also we did several robustness checks to make sure. Another robustness check we did was something called the placebo test. We changed the treatment point. So we randomly select a different period to make sure that particular time we choose as a treatment point is not effective. So in the second one, we found that as people use more emojis, their language becomes more standard, meaning that the non-standard usage is going down. So overall, these findings suggest that emojis are actually performing the similar role of emoticons and non-standard words, which are known to be conveying social information, additional to the verbal information in text. So kind of the takeaway from this work is that we found this emoji is a new type of interventions that was kind of introduced to different social platforms, and we use this textual content from this platform for various different studies. So the studies suggest that emojis perform kind of similar role of conveying social information. So we should be kind of adding include these as features in our models or inferences.
What about controlling for age of the person?
So yeah, that's a very good question. So we could also control for age and like other social variables. So we control for the pre-treatment writing style as a kind of a characteristics for those all possible confounds. So because it's kind of hard to infer age and all these possible kind of confounds, we consider that those all will be like reflected in their writing style. So that's why we kind of control for the pre-treatment writing style.
Also, one question that I was discussing this with Goran, that it's true that some applications, when you add the emoticon, automatically to the emoji, right? So maybe that's also one of the sources for
yeah, so when we looked at that, how it's represented, like in the kind of actual metadata, it's the Unicode character, so we'll be able to differentiate. And we also matched for this the client. So if there's any such cases, then it would also kind of control for that.
I have just a general question. I'm not a big emoji user because I frankly find there's a huge cognitive cost to finding emojis. Is there a way, like, just do you take that into account, the way to measure what the cognitive cost, how easy it is to?
Yeah, we have not done that, but there's some work from Minnesota where people have looked at like the cognitive aspects and also kind of how kind of interpretable is that. There's some kind of qualitative study where people looked at like this, some of the emojis have this kind of group meaning, so and also like in relationships. So maybe a partner you'll use different type of emojis, friends you'll type different type of emojis. So there's this a whole lot of new kind of new sub areas. Yeah. So the second study I'm going to talk about is the effect of banning hate communities on Reddit. So what happens when forums for hate speech are shut down? The question is whether people export such hate behavior elsewhere, or the eliminating these echo chambers reduce the hate speech overall. So in 2015, Reddit shut down several subreddits because of the violation of its anti-harassment policy. So two of the notable ones are Fat People Hate and Coontown. So this gives us a natural experiment to study the effectiveness of banning as a way to kind of diminish the hate speech. So quick overview of the subreddits. So the Fat People Hate is a fat shaming subreddit dedicated to posting pictures of overweight people for ridicule. So caution about some kind of inappropriate language here. So here's this typical example comment you will see in this forum. So this forum has about 150,000 subscribers when it was banned. And the other one is Coontown. So this is a racist subreddit dedicated to violent hate speech against African Americans. It has about 20,000 subscribers, and this is like a typical comment you will see. So if you want to study kind of the effect of banning on hate speech, we kind of designed this as a causal inference experiment in this way. Here the treatment accounts or treatment users are people who posted in these banned subreddits. If Fat People Hate or Coontown. So we need to select control users who are kind of similar to these treatment users, but not kind of affected by the treatment. So one way to look at is this. So what we did was we first selected a control set of subreddits instead of users, which are likely to be banned. So how we found this is we looked at where these treatment users, where are the other places these treatment users posted. So because these treatment users they post to the banned subreddits, maybe they prefer that type of kind of language or communication. So we looked at subreddits where else they posted, and we consider them as likely to be banned. So those are our control pool of subreddits, and then we looked at like users who posted in those subreddits as our controls. So here, like our control set is also like likely to be banned, but they did not get banned. And then we selected the control actual matched pairs using Mahalanobis distance on controlling for several coin farms. So one of the challenges in this work is about measuring hate speech. So there's no universally accepted definition of the term hate speech. And one of the widely used terminologies from the European Court of Human Rights, which tells that like any comments which are necessarily directed against a person or a particular group of people focusing on race, religion, or the other. So because of this kind of lack of a definition, in our work, we looked at kind of a usage-based approach. Because these subreddits were banned, we could assume that these are characteristic of hate speech. So the content of these subreddits are characteristic of hate speech. And what we did was we identified words which are unusually frequent in these subreddits using an automated technique called Sage. And then to validate like the output, we looked at the top 100 words, and then manually removed some of the words which are not intrinsically linked to hate speech. So one of the top terms of variance of this name of the subreddit itself. And then about like people have called this posting hate content in using different words. And then there are also some words which are kind of related to the subreddits, but most of the often they're used in non-hate speech content. Like IQ you would see in Kuntown, and welfare you see in Kuntown, and then cellulite you'll see in fact, but they're not directly indicated. So we did it like on manual annotations, and we got a good agreement. But we did all our analysis using both this automated lexicon and this manually filtered lexicons, and the results are qualitative. So now this is the effect of hate speech after the ban. So this is for Kuntan, this is for fat people hate. And here we see a clear decline in both cases. So this is the change in hate speech uses by this treated, and the gray ones are control use. So we did not see any kind of significant changes in pattern for the control use. So to quantitatively measure this, we used another difference in different approach where we modeled the amount of hate speech in terms of the time and whether it was pre-treatment or post-treatment. And we look at these coefficients, and then the significance, we find that there's a significant drop.
What do those numbers mean? Like,
sure. So in this one, it says that there's about 1% drop. So the overall, in fact, people here's there's about 0.2 to 0.4% usage of hate speech.
Individuals, like random person, there's that much less than.
And then so there's 1% drop is significant considering that range. So we did several, again, robustness checks to make sure this is actually an effect of the treatment. So this work got a lot of press attention, and there was a post about this paper and which got to the front page of Reddit. And Redditors were having serious discussions and asking some of the hard discussion for us as researchers. For example, how do you kind of measure hate speech, and if you do manual annotation, like do you have biases, and all these kind of different challenging questions, which is really interesting. And a few months later, Reddit banned another set of violent subreddits. And there was some kind of discussion and speculation on Reddit that it could be because of some of the lessons from our study. So this is kind of an example of how like computational social science research could kind of tackle some of these high stake questions, and how we can kind of like find kind of different outcomes. So a question about why did work for Reddit. It could be because Reddit had this kind of federated approach. It has like Reddit as a community and has several sub-communities. So maybe it's because these hate communities are kind of concentrated in different sub-communities. Maybe it's easy to ban them and it works. But the question is the similar approach for example, Twitter, where we don't see such kind of like subgroups. And then some users went to other sites like sport, but it's still, I think it's a win for Reddit if they want to eliminate hate on their side. And then the other question is, our algorithms actually detected only a specific subset of hate speech. So it could be the case that hate speech could have shifted to a different form that's like harder to predict. So that's kind of the end of the second case study. And let me quickly talk about the third one. So in the case of Reddit, it had a problem, hate speech. The management or some moderators took this action of banning some of these threads. Now let's consider Wikipedia. Wikipedia is known for its to be successful online collaborative. And the norm enforcement here is also the decisions are made and done collaboratively by these editors. So Wikipedia is known for its strong guidelines about writing style norms, that it should be like objective and non-biased. So one such norm enforcement is called NPOV or neutral, because it's encyclopedia. We should not bring our attitudes as editors. It should tell things in a neutral point of view. So it's characterized in the language. So while this approach of norm enforcement has been in place in Wikipedia for a long time, there's no empirical research to kind of find the effectiveness of this norm enforcement. So whether tagging an article as NPOV helps to improve the quality of the article. Whether correcting an editor for NPOV helps them to improve their writing quality. So we looked at this as a causal experiment. So we have a corpus of NPOV articles and we detected when it was tagged and removed and when the user was corrected, and then we identified treatment and treatment users. But one of the challenges in this work is to identifying the controls. So we have articles which are tagged with NPOV as our treatment, but to select the control, there's a large pool of articles, and also what kind of attributes to match on these articles. So in the case of the users or editors, what we found is these editors are systematically different from the rest of them. So we could not use the approach we used in the previous two case studies about having this treatment and control. So we used another causal inference technique called interrupted time series analysis. So which is a quasi-experimental design way to kind of evaluate the longitudinal effect of an intervention through a segmented regression. So this is quickly how interrupted time series work. So this is the pre-treatment trend. If there's nothing happened, this is what have been happened. And then if this is what we observe now, so there could be the level change and also there could be a rate change or a slope change. So we could model this as a segmented regression and then look at this coefficient, characterize level change and slope change. So we looked at this for both articles and the editors. And the summary is that we did not see any, for the articles, we see a significant drop in their kind of biased language. So it means that the articles improved when it's tagged, but at the editor level, we did not see any significant changes in their writing quality. So maybe we need to have a different type of interventions to kind of help the editors in a different way. So coming back to the challenges of I talked at the beginning about representativeness and feasibility of using doing randomized experiments. And the last one is about validation and evaluation. I've also done some work in this, and I'm not going to talk in details, but quickly tell you about this, and if you're interested, we can talk later. So in the one is, as I mentioned before, when we use computational models to kind of characterize social science intuitions or theories, we need to make sure that they're actually capturing what we wanted to capture. So, and they're interpretable. So we wanted to kind of characterize language style in different subreddits so that we can study different kind of downstream phenomena. So we use the sociolinguistic construct and then use an unsupervised way to extract several dimensions of linguistic style. And then we had to go through several steps of validation to make sure that whatever our model captures is actually meaningful. So one such validation technique we did was, so we extracted like different dimensions, and then we used the word intrusion task. We intruded a set of words from our dimension with another, like an external word, to see if people can detect that. So in that case, it will tell that these are coherent and then kind of meaningful. So we did several set of validation. Another validation technique we used is called pre-registered hypothesis. From the previous research and knowledge, we like write down some hypotheses before we do the model. And then after we do the model, we go and check if those hypotheses are valid. So in this case, for example, we know that some of the words should group together. For example, effective words should group together. So we wrote down those hypotheses and tested after the model and validated that it's meaningful. We also did several kind of downstream kind of prediction tasks to validate. So now that we have this validated model, we can use that to study various phenomena. Something I'm currently working on is looking at when people post multiple separates, whether they change their writing style, and how does that affect the feedback they get from their feedback. So I have another work in this direction. You can just if you're interested. So this is kind of to summarize. Today I've talked to you about kind of some of the challenges which I addressed in some of my work. And I hope that I have convinced you that combined with new data sources and computation, we can measure and understand social phenomena and like address some of the social science, like social challenges at scale. And in terms of quickly about future work, I'm really interested in studying like online and offline human user behaviors using different linguistic, structural, and social networking patterns. And some of the kind of immediate directions I'm interested in is about compacting negative behavior, such as like hate speech, incivility, and trolling. These are not just like issues for the platforms, but also have a larger like issue as a societal problem of, for example, like polarization. So I'm kind of broadly interested in studying such a negative experience and also a lot of like cyber threats. And then I'm also interested in like how we can use data-driven models to kind of characterize several kind of phenomena, user behavior, and then use those models to study new questions, validate theories, and also like kind of introduce new hypotheses. So I would like to acknowledge my advisor, Professor Jacob Eisenstein, Georgia Tech, and also my undergraduate mentee, Shojan Khan, who I've been working with in some of the recent projects, and some my long-term collaborators from the Sociolinguistic Department of University of Pittsburgh, and Professor Adam Green at Political Science at Emory, who we have been collaborating on the social interest stuff, and a lot of others at Georgia Tech. So this is some of the references about the work, and thank you for listening, and I'm happy to take questions.
From the audience, so in NP video work, actually the neutral point of view that was somebody has to come in and tag an article as lacking a neutral point of view.
So the editors, so editors have different roles. Some of the editors, they create new articles. Some of them kind of do this kind of moderation task or administrative task. So people will go and tag an article with NPOV, and then you will see this tag on top of the article.
So it's some different populations of editors.
So editors have, I mean, it could be the same person could tag and they could like kind of make it better. So this is kind of an obvious signal which is shown on the page. So the one reason that we see a kind of an improvement at the article level is because there's like something which is on the page that maybe kind of attract more people to go and edit that. Whereas at the editor level, it's like, it's still kind of, there's not a lot of visible kind of cues about that someone's language, like contribution was correct.
Well, because this tag would be about content that's been generated by many different editors, right? So it's not clear who exactly.
But then the editors knows that because most of the editors follow this kind of track changes, and they know that the contribution was edited, but it's not visible as this.
Mm-hmm. One more question, so all of your work has been mostly directed at language and listed using languages to do causal inference. Do you think the methods would also carry over to other types of behaviors?
Definitely, because I kind of, for my thesis, I started working in physics, and for my thesis, I have to narrow it down to one kind of area. So I kind of focused on language. But definitely, I think I've kind of done, so I think the hate speech work is also like based on language, but it's a different type of, like compared to my other work, it's a kind of a different like
But if you're looking, for example, at whether something makes people exercise more, something like this.
yeah, so I think
Exercise is not this kind of very social.
yeah,
type,
but
like,
I think there could be other, for example, I mean, one thing we can like look at is whether people are talking about exercising. So that's kind of one way to kind of measure if they are kind of interested in exercises. There could be other signals that could be characteristic of exercise. So maybe they're using an app, a running app or something, and reporting that in social media. So this kind of, so yeah, definitely these methods are not just limited to language. So these could be used for other type of like variables, kind of just like numeric kind of variables too. So and also like I think we use language, but it's also at the end we need to kind of quantify language in different ways. So it's kind of, so we look at the rate.
But one more difference might be with this is the behavior that are observable by your social peers, so there's an incentive for you to, it's like they're more like normative behaviors where there's incentive for you to be socially coherent, conform, sort of conformant, whereas other behaviors may be more independent of that and might be more difficult to observe.
In this kind of, so this is like, so here I think the interventions are kind of clear. I think in the examples you maybe the interventions are not clear, but I think there is some work about kind of using kind of reporting to peers and reporting in social media as this external signals. Maybe not just one signal, so we might need to combine multiple signals.
That's a question. So if as soon as you report, whether there's now social pressure to conform, as soon as your behavior is visible to others.
Yeah. So then maybe we could need to control for like the network of users we have, like how much of maybe like do they also doing similar activities kind of. But I think like we could just use this similar approach, but we might think more about the confounds and what's the treatment, what's the outcome, what's the dependent variables.
Are there any other questions? From NLP crowd? All right, well then let's thank Umashanthi again.
Yeah, that's fine.
It's not just limited to online, which I'm interested in. And moving beyond this online, it is